we're going to look at another topic called even and odd function. And again, it may be hard to appreciate the purpose of all this, but safe to say, it is important. Otherwise, we would not be entertaining these ideas. I have better things to do in my life than wonder about these things. Part of the usefulness of this topic is analysis and solving an equation when it comes to the process of solving. That's one thing. As a computer programming, these concepts are essential because they give you insight into things. In other words, when you code, you try to code as efficiently as possible, and knowing certain attributes allow you to code more efficiently. So let's first look at its definition. Given the function f of x, the function is defined as even if the following is true. Now, meaning f of x equals f of negative x. But what does this mean? Well, look at, now that we know transformations, and if you're watching this video, you've never seen transformations, definitely understand transformations. What it says is flip across this means flip across y-axis. Okay, if you flip across the y-axis and you wind up with exactly the same function, then it is called even. So again, let's look at a particular function, the absolute value function. Is this even function? Is f of x equals absolute value of x even? Well, notice what I said. If I take it and change it to negative x, what happens? It flips across the x-axis, but this thing is symmetrical around the y-axis, so it would flip back on itself and you would not be any wiser to it. But let's test this out. What happens if now here's, again, would you call this a proof? Yeah, so like proving it, so to speak. So I'm going to test it, prove it, however you want to think about it. And this is something you'll be asked to do. Take and change x to negative x. So what does that mean? I'm going to go inside these absolute value symbols and change that. So what is this saying? Whatever you input here, take the opposite of it, and then take the absolute value. So again, imagine taking the -5, the opposite of -5 is 5. If I enter 7, the opposite of 7 is -7. But what happens here? Well, every time, no matter what I enter, it seems to strip away the sign. It's really just a distance away from 0, but distance is thought as positive. So no matter if I enter this, the absolute value is going to eventually wipe it out. So in other words, this would provide the same result as if I had done nothing to it. So whether I use opposite of x or just the absolute value of x, the result will be the same, thus the equal sign, which means that this is f of x, and there you have it. This is even because when I change that variable to the opposite of, it doesn't do anything. I go back and I have the original function. Nothing has changed. So this is even. Okay. What happens if the function is defined as odd? Well, there's a couple ways of doing this. A function is odd if the following is true. And this is my version. I like this one, personally. It's not the one you find in the textbook. But what it says is, find the opposite of x, find the opposite of the y, and then you wind up exactly where you started with. So really what this is saying is two things. Flip across x-axis, or actually do the y-axis. Let's do the inner part first. Just like before, flip across x-axis. And then what happens? Nothing happens. You just go back to what you started off with. Now, so basically what is happening is I am flipping across this axis, and then I'm flipping across this axis. Notice if I did this with the absolute value, I would see that I get a different cross. So notice f of x equals absolute value of x is not odd. And why is that? Because let's just follow it. Imagine taking this, flipping it across the y-axis. I also going to get the same thing again, which is great. But if I flip it across the x-axis, what I wind up is this picture right here. So flip across the y, just nothing changes. Flip across the x, you get this. So all of a sudden, I do not get the same picture. So this is not odd. This other expression, the one you find in textbooks, is probably better for just testing this whole thing out. Okay, but maybe not. I think this is also as efficient, if maybe not more efficient. It doesn't really matter. So, can you give me an example of an odd function? Well, yeah, let's just kind of go one. I use absolute value here. Here is an interesting one, as written. Oh. X cubed. I claim f of x equals x cubed is odd. I don't know what this looks like. This is one of your basic functions. Sometimes also people call it the parent function. So now let's see if this is odd. First of all, let me apply this one first, f of negative x. So for example, if I was trying to prove this, I would go, okay, well, f of negative x, what is that? So it would be the following. Now, what happens when you take negative x times negative x times negative x? In other words, this. So the opposite of the opposite is positive. And now x squared times x is x cubed, and then this is just says, well, I take the opposite of it. So that's the result of changing f of x to f of negative x. Okay, so I get this. Now, what this one says is, hey, take the original one and or take the opposite of that. So here's the original one. Now, what does it want me to do? Take the opposite of it. So I take the opposite of it, take the opposite of it. What do I get? Well, I mean, there's nothing to do with it. That's it. Take the opposite of both sides. There it is. Hey, wait a minute. Look, f of negative x equals negative x cubed. Opposite of f of x equals opposite of x cubed. In other words, there it is. These two are the same. So look at that. I got f of negative x is equal to opposite of f of x. This is odd. Okay, this is odd. So what's I get one view of it? Well, look, what it's saying to do, if this happens, then it's odd. Visually is flip across the y-axis. This point is here when I do that. Flip across the x-axis. When I do that, boom, there it is. So flip twice, flip across y, flip across x, and all of a sudden I land back on the graph. If I can do that, it's odd, right? The whole point is I can't tell, for example, even though this point did get transformed when I did that, now it's down here, it's back on the graph. So I wouldn't know if you show me this graph, it goes, where's that point now? I'll go, I don't know, it seems to be there. It hasn't, this one's gone up there, this one's gone down there, but I can't tell anything. And that's what's happening here. When I do these operations, the function seems to not have changed at all. And that's what makes it odd. So let's look at this one right here. This is the cosine function. Is the cosine function, which equals y equals fx, odd, even, or neither? None of these things. So now I'm looking at this function and let's see, is it even? So let's go back to this example. If it's even, it seems to reflect across this y-axis. Okay, if you think in other words, it's like a mirror image, like this point's looking over here and then the seeing its reflection over there. So the two is just a mirror image. If I were to able to fold this piece of paper, this point would just land on that point. And I'm looking at here and goes, wait a minute, there is sort of a mirror. Here's the y-axis. Yeah, there's like a mirror image. I can see that now. Like for example, this point, if I were to move, seems to this point and this point they're the same distance away from the y-axis. So yeah, it's like a little mirror image. Yeah, this point is over here on the other side of this, same distance away from the y-axis. This point is over here, and look at that, same distance across the y-axis. So it seems like I took this piece of paper, marked it, and flipped it across the y-axis, and the whole graph flops on itself. In other words, what must be true then is that the cosine of x is equal to the cosine of negative x. Flip everything, and indeed you wind up with the same result. Nothing here is going to change. Okay. Now, I won't do this with a cosine function, but I'm going to do this with the absolute value function, just again to make sure you understand what I just had to say using a cosine as an example. Let me just use a few points, not a lot. A few points. You could do more points later if you want. As a matter of fact, I'm going to skip. Okay, that's it. So the absolute value, if I enter -2 into this, the absolute value of -2 is 2. Enter the absolute value of, excuse me, let me do one more here just to make sure we got this. Otherwise, the point is not going to be made. Great. If I enter the -1, the absolute value of -1 is 1. Enter 1, you get +1. Enter 2, you get -2. Okay, great. So what am I saying here? Well, it's even because here's this function, but if I were to now look at the following function, what happens to it? Well, remember, what I'm doing here using transformations is these here stay exactly the same. I'm not touching the y-axis, but I am taking the opposite of everything I enter into the x. So what's the opposite? The opposite of 2 is 2. The opposite of 1 is 1. The opposite of +1 is -1. The opposite of 2 is -2. And there you go. Before -2 went to 2, -2 goes to 2. Before -1 goes to 1, -1 goes to 1. Before 2 went to 2, well 2 does go to 2. 1 goes to 1. Yeah, 1 does go to 1. So nothing's happened, nothing's changed, and that's what makes it even. Let's look at another example here. Is a sine function y equals sine of x odd, even, or none of these two? All right. Clearly, I can see now, having used this example, it's not even because I'm looking across and reflecting across, and it's not the same picture when I reflect across the y-axis. Great. But is it odd? And remember what odd is. It's two reflections happening at the same time. It is reflecting across this axis, the y-axis, and then reflecting across the y-axis and then landing back on the graph. And it seemed to be doing that. Again, is that about right? Looking at that distance. Oh, it's kind of hard to tell. It's not, this is not exact. But yeah, if I flip across, sure. And then what happens? I look at this distance, which is 1 block high, and this is 1 block high. Sure enough, if I take this and flip it across this axis, again here, notice this block, this is 1 block, and this is 1 block. Yep, it's exactly that. That point gets flipped across the y-axis, then flipped across the x-axis, and you'll land back on the graph. Is that true for everything? Well, how about this distance over here? Again, you can't see it. Let's just go for this one. That distance. Okay, so now we flip it across the this point, and where do I wind up here? Somewhere here. Well, yeah, it's just shy of 5. So it's right there. This is just shy of -5. Then flip across the x-axis. Boom, there it is. So yeah, this function is odd. Okay, this is an odd function. Again, what does it mean to do this? Well, let's look at again the definition of odd. And I'm going to use the table. So let's look at x and x cubed. And again, I'm only going to pick a few values. -2. When I cube this, it gives me negative. 2 times 2 is 4, times 2 is 8, so -8. If I enter -1, I get -1. If I enter 0, I get 0. If I enter 1, I get 1. If I enter 2, I get 8. Great. But now what it's saying to do is the following. I'm going to do it in one shot. Take the opposite of x. So if I go back to this original definition, my favorite one, take the opposite of x and take the opposite of y. That's what it's saying. So now I'm going to come over here and do both. So I'm going to come over here. Okay. Take the opposite of x, 2. Take the opposite of y, 8. Take the opposite of -1, 1. Take the opposite of the y of -1, 1. Opposite of 0, 0, opposite of 0. Okay, that doesn't change. Opposite of 1, -1. Opposite of -1, -1. Opposite of 2, -2. Opposite of 8, -8. And I've done it. So has something changed? Well, before, -2 goes to -8. -2 continues to go to -8. Before, -1 went to -1. -1 still goes to -1. 0 goes to 0. Okay. 1 used to go to 1. Well, 1 used to go to, it goes to 1 still. 2 goes to 8. Well, 2 still goes to 8. So you'll notice the points have changed, but I'm flapping down on the same part, so you can't tell the difference. So if I ask you, is this set of ordered pairs the same as this set of ordered pairs? And the answer would be, yeah, it's the same.